the third example. Now the third example is very similar. Okay, again the balanced chemical equation has been provided to you. Calcium reacts with hydrochloric acid, gives you calcium chloride and hydrogen. Okay, and then the question says, in an experiment, 20 gram of calcium is added to 200 cm cubed of 2 mole per dm cube hydrochloric acid. Identify the chemical reactant, limiting reactant. So similarly, whenever the question asks you to identify the limiting or excess reactant, you have to compare what is in the theory with the actual. So the theory say 1 mole of calcium reacts with 2 mole of hydrochloric acid. Okay, 1 mole and 2 mole. Now we have 20 gram of calcium. Now actual, we have 20 gram of calcium. 20 gram of calcium is how many mole? 20 divided by AR. AR for calcium is 40. So 0.5 mole. Okay, 0.5 mole of calcium. How about for hydrochloric acid? So you have to find out the number of mole of hydrochloric acid. 200 cm cube, 2 mole per dm cube hydrochloric acid. How do you find the number of mole? So the number of mole here for hydrochloric acid, okay, the number of mole here would be your volume. You just look at the unit. When the unit, this cm cube we have to change to dm cube. If this one is dm cube, so dm cube times mole per dm cube, you get mole. Okay, let me show you. Okay, 200 cm cube. How do you change it to dm cube? 1 dm cube is 1000 cm cube. So 200 cm cube would be the same with 200 divided by 1000, and this one would be your dm cube. Okay, and then after that you have to multiply by the concentration. The concentration is 2 mole per dm cube. 2 mole per dm cube. Why do I multiply? Because when I multiply, this dm cube and this dm cube would cancel off. When this dm cube and this dm cube cancel off, that would give you mole, which is exactly what we want. Okay, so a lot of times you have to play around with the unit in order to get what we want. Okay, so this is 0.2. 0.2 times 2, that will be 0.4. So it is 0.4 mole. Okay, so you have 1 mole to 2 mole, 0.5, 0.4. Again, the basis of comparison must be the same. So we can change this 1 mole to 0.5. Okay, if every 1 mole, now if every 1 mole of calcium, you need 2 mole of HCl. What if the calcium I only have 0.5 mole? Then how much of HCl will I need? That will be half, right? 1 mole. Okay, if I change it, if I have 0.5 mole of calcium, in theory, I would need 1 mole of HCl. But now, how many mole of HCl do I need? Do I have? Now, I have 0.5 mole, 0.5 mole. But now, I only have 0.4 mole of HCl. By right, I need 1 mole. Now, I have 0.4 mole. 0.4 mole is less than 1 mole, therefore your HCl is your limiting reactant. Okay, so your limiting reactant is your hydrochloric acid. Alright, your limiting reactant is your hydrochloric acid. Now let's go on to calculate the volume of the gas, of the hydrogen gas produced. Again, the volume of the product, your hydrogen gas is your product. Okay, your hydrogen gas is your product. So the amount of product produced in a chemical reaction depends on the limiting reactant, which in this case is hydrochloric acid. How much hydrochloric acid is used in the reaction? 0.5 mole. So volume of hydrogen gas produced, you have to look at the mole ratio of the limiting reactant, which is HCl, as well as what we want to find, which is hydrogen. What is the mole ratio? The mole ratio is 2 mole to 1 mole. So the mole ratio is 2 to 1. Now, in the reaction, in the experiment, how much of HCl do we use? 0.4 mole. So now we have 0.4 mole. 2 is to 1. That means this side must be half. So this side must be half. Right hand side must be half of the left hand side. 1 is half of 2. So half of 0.4, 0.2 mole. So that means if you use 0.4 mole of hydrochloric acid, you would get 0.2 mole of hydrogen. Now 0.2 mole of hydrogen, what is the volume? What is the volume of hydrogen? We know that 1 mole of any gas would occupy 24 dm cube at room temperature and pressure. Now this one should be volume of a hydrogen gas produced at room temperature and pressure. Okay, 1 mole occupies 24 dm cube. So 0.2 mole, the volume would be 0.2 times 24, and that would give you 0.4. I mean 0.2. That would give you 4.8 dm cube. Okay, so 2 is to 1, 0.4 is to 0.2. Now let's look at the last question. Last question is very simple. It's concentration. Concentration of a hydrochloric acid solution is 20 gram per dm cube. What is the concentration in mole per dm cube? So gram per dm cube change to mole per dm cube. It is just like gram per dm cube. How do you change it to mole per dm cube? Mass, how do you change it to mole? So it must be mass divided by mR. So your 20 gram per dm cube must be divided by the mR for hydrochloric acid. Okay, your hydrochloric acid is HCl, the mR is 36.5. So 20 divided by 36.5, 0.548. 0.548. So that would be your answer. Very simple. Gram per dm cube change to mole per dm cube. Just look at, because the bottom part, the denominator are the same, so you just look at the numerator. So mass change to mole. Mass divided by mR is the mole. Yeah. Okay, the second part, how many mole is in 100 cm cube of the HCl solution? Now this HCl solution, the concentration is 20 gram per dm cube. What is the meaning of 20 gram per dm cube? 20 gram per dm cube means 20 gram over 1 dm cube, which means that in 1 dm cube, okay, this one it means 1 dm cube, it has 20 gram of HCl. Now we have 100 cm cube. How much? 100 cm cube is actually 100 divided by 1000, which is 0.1 dm cube. So 1 dm cube, 20 gram. 0.1 dm cube, that will be 2 gram. So 2 gram of HCl. But the question wants how many mole. So you are given mass, you want to find how many mole. So your mole would be your mass divided by your mR. Okay, your mass over here, you found out that it is 2 gram. So 2 gram divided by the mR. mR for HCl is 36.5, and that would give you 2 divided by 36.5, 0.0548 3SF mole. Okay, Okay, that would conclude this lesson on more difficult mole calculation questions. So what you can do after this is to download this worksheet, the worksheet that accompanies this video, then redo the questions on the worksheet, and you can always refer back to this video for answers. Bye bye.